Okay, today we are going to learn about how to analyze something via audience. So what we are going to use is the FISH dataset. Okay, so what is FISH? So this is FISH dataset. When you do your exam, I will give you one dataset, and I will give you also the data description. So the data description will be something like this one. There will be the column name, what is the column name, and there will be like description. So similar like the assignment. And then you will see like this name, the column name species is the fish species. And then the column weight, it means the fish weight. Length 1, the length 1 or the standard length. Length 2 is the fork length. The length 3 is the total length. And then the head is the fish head, and width is the fish width. If you look at this fish, this is the standard length. Okay, so the standard length is from the mouth until this part. And then we have the fork length. So the fork length. Now this is the length number 2. So the fork length is from this part until this part. And then I have also the total length. Okay, the total length is the length 3. So this is from the mouth until the end of the body of this. So we have 159 data. And this is the example of the data. So we have the species, weight, length 1, length 2, length 3, head, width. So 159 fish data has been collected. So suppose we want to predict the weight. Okay, so it means I have those information. I have this information, and I want to predict the weight. So let's assume you have some kind of camera. So you have the camera to look at the fish, and the camera can directly recognize the length. Then the camera can recognize the length 1, length 2, length 3, and then the camera can also look at the head and the width. Then how can we predict the weight? So we can make a kind of model. So let the target is the weight. So the target is the weight. This is the target, and the other will be the feature or the variable. And let's do one by one. How can you do it with points? And then how will you do during the exam? So since the target column is numerical data, then we will do regression. Okay. Now let's see. I have downloaded the file. Okay, so I have the file here. If you look at this widget, we have species, and it is categorical. And you can see the values here. So the species name is bream, parky, perch, pike, roach, smelt, and whitefish. For the numerical column,
it is just mentioned as
numeric.
Now
Now
we need to
set
set
up
up
based
on
on
this information,
set
set
the
the
width
width
as
as
a
a
target.
target.
Why? Why
We set the width as a target
Because
because
based
based on the problem,
we
we
want
want
to
to
predict
predict
the
the
width.
width.
Because
Because
we
we want to predict the width, then the width is the
target. So we can set
set
up
up
the
the
width.
width.
Here
Here
it is
it is
numeric,
numeric,
and you
you
can
can
see
see
in the
in the
rule
rule
you can
you can
change
change
the
the
rule
rule
not
as feature, but
it
it
is
is
target. So
you
you can
can
change
change
here
here,
or
or
you
you
can
can make
kind of select column and
and
determine
determine
the
the
target.
target.
So it is the same. If
If
you
you
want
want to do like this one,
and then let's
let's
say
say
you
you
want to
want to
use
use the select column.
So you can use the select column,
column,
and then
and
you
then you
put
put
the
the
width
width
here.
here.
So it is
It
the
is the
same.
same.
Okay. So the remaining
Are
are
the features
and the
the
target
target
is
is.
so
So
depending
depending
on
on the problem,
you
you
can
can
set up
set
the
the
features
features
later.
later.
Yeah,
You can determine, for example,
okay,
okay,
I
I
don't
don't
need to
need to
use
use the species. I just want to use
all the
all the
numerical
numerical
values.
values.
That's
That's
also
also
possible.
possible.
I
I
want
want
to
to
use
use
only
only
the
the
rank
rank
1,
1,
rank
rank
2,
2,
rank
rank
3
3
with without
without
width.
width.
So something like this.
It
It is
is
also
also
possible.
possible,
And
and
etc.
etc.
So
So
let
let
me
me
just
just use everything here.
So you can also change the
The
sequence.
sequence.
If you
If you
change
change the sequence,
it
it
means
means
this
this
one
one
you
you
will
will
see
see
this
this
on
on
the
the
sequence
sequence
on
on
your
your
features.
features.
The
The
first
first
is
is the
species,
species,
length
length
1, length
length
2,
2,
length
length
3,
3,
width,
width,
and
and
height.
height.
So
So
this
this
is
is
based on
based
the
on the
sequence
sequence
that
that
you
you
already
already
determined
determined
here. Species, length 1,
Length 1,
length 2,
length 2,
length
length
3,
3,
width,
width,
and
and
height.
height.
Now, let's
Let's
look
look
on
on
the
the
problem.
problem.
Do you still remember?
What is EVA?
What is EDA?
EVA?
It
It
is
is
the
the
exploratory
exploratory
data
data
analysis.
analysis.
So
So
we
we
want
want to know
the
the
statistics
statistics
of the
of the
data.
data.
So
So
let's
let's
say
say
in
in
this
this
problem
problem
we
we
have
have
4
4
questions.
questions.
Okay, so in
In
the
the
mid
mid
exam,
exam, I don't know how many questions it will be.
but let's
Let's
see.
see.
Show the average
Average
weight.
weight.
I
I
think
think
based
based
on
on
the
the
assignment,
assignment,
you
you
know
know
how
how
to
to
figure
figure
out
out
this
this
one.
one.
Show the
Average
average
weight
weight
based
on
on
the
the
species.
species.
Do you think the
The
average
average
weight
weight
for
for
all
all
species
species
are
are
the
the
same?
same.
Explain.
And
And what
what
are
are
the
the
distribution
distribution
frequencies
frequencies
of
of
species?
species?
Okay, so
So
let's
let's
see
see
one
one by one.
how
How
to
to
show
show
the
the
average
average
weight.
weight?
You know, we
We
can
can
do
do
the
the
feature
feature
statistics.
statistics.
Based
On
on
the
the
feature statistics,
we
we
can
can
see,
see,
okay,
okay,
the
the
average
average
means
means
the
the
mean.
mean.
And
And we can say that the average is
398
398 something something.
Okay.
And
And
then
in the
the
exam,
exam,
please
please
make
make
sure,
sure
please
please
write
write
the
the
comment.
comment.
The
The
average
average
weight
weight
is
is
398
398.326. Okay. 398.326.
So if you write this one, then I will give you point. Okay. So you need to mention this during the exam. Then show
Show the average weight
is on the species.
species. How can we do this one?
If you
Look
look
at
at this
this
species, we
we
have
have
bream,
bream,
and
and
then
then
we have roach,
roach,
we
we
have
have
white fish,
fish,
parky,
parky,
birds,
birds,
pike, smell.
smell.
So we don't need to know what is the shape of the fish, but at least we know that there are some species. At first, maybe you want to see the distribution. Yeah, you can check. Based on the distribution, we have, okay, let's say bream. So bream, we have about 35.
Wait a moment.
Yeah. So we have 35
bream.
bream. And then we have 11
parky.
we have 56 birds and so on. Now, how can we know the average of this? There are many ways. Okay. You can use, for example, I want to look at the bream. Then you can click on the bream. It means I'm selecting this data. And then you can do the feature statistics. So this feature statistic will be only the average for bream. So the average weight for beam is 16117. Then you can write, let's say 2A, for example. The average weight of beam is this one. 617.829. 617.829. Like this. Then how can I do with the remaining? Parky, birds, pike, and so on. Yeah, if you want to do manually, you can do another distribution and you can select the data again. If you select this, if you click this one, then it means I'm selecting the data party, and then I can do the future statistics. Then I will see the weight. This is 154.818. So can have again to be,
For example, the average
weight of party
parky
is
is
what
154.818.
Okay,
154.818.
and so on. Okay. So you can also do like this for different kind of fish. This is the simple way. But you can use some other way. For example, we can use
a box plot.
the last time I
teach you how to use the box plot.
Yeah, so
This is the feature statistics.
Okay. So using the feature statistics,
we can see the mean or the average of all
fishes. And using the box plot, we can compare the mean. Okay, so last time you learned about the box plot. Box plot has 5 number summaries. You still remember? Yeah, it was in the exam. The illness we have the minimum, maximum, Q1, Q3, and median. Okay. Then I can use the box plot to see the so I can use the box plot and you can set up the variable. So the variable that I want to look at the box plot is the width. And then this is the overview of the piece. You can see the minimum is 0, maybe this very small fish, maybe, or this is no data. And this is the Q1, Q3. Okay. And above this one, it is the possible multiplier. Above this one, also this is a possible multiplier. So the maximum value is 1,600 something. Now, if I want to see the average of every fish, you can look at this one. It's on the subgroup. So the subgroup is the species. So I click the species and you can see the box plot will be for every of the fish. So this is the average of smell. This is the average of roach. This is the average of parking. This is the average of birds. This is the average of whitefish, bream, and piper. Okay. So you can also use this information. Okay. So you can use this information to for the answer of your exam. Let's say. So using the box plot, you can type 2. Okay. Beside the box plot, you can write 2. The average weight is as follows. So bream. Then you can mention 1, 2, 1, 6, 7, 8 to 9, and then what is the turkey, how much, and then other things. Okay. So you can write down like this one during the exam with the orange. Now, if you look at this, the orange provide min and median. Okay. Min and median. 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 So you need to distinguish which one is min and which one is median. Now, the next question is, do you think the average weight for all species are the same? So do you think the mean or the average weight for all species are the same? If we look at the smell, the average is 11. If we look at the average is 152. If we look at the pike, the average is 700 something. So what do you think? If we use this visualization, it seems they are not the same. This fish is very small. This fish is very big. Okay. But how can we verify that this is not big? So you
You
can
can
see
see
when
when
I
I click
annotate,
annotate,
so
so
every
every
of
of
this
this
data
data
will
will
appear.
appear.
Will
When
I
I
unclick
unclick
this
this
annotate,
annotate,
then you
then
will
you will
see
see
there
there
is
is
one
one
of
of
this
this
figure to mention about ANOVA.
ANOVA.
So
So
what is
what is
ANOVA?
ANOVA?
It
It
is
is
the
the
analysis
analysis
of
of
variable.
variables.
You will
You
learn
will
more
learn more
about the
about the
ANOVA
ANOVA
in
in
the
the
statistics
statistics
class,
class.
but
But
for
for
now,
now,
let's
let's
just
just
figure
figure
out
out
the
the
numbers.
numbers.
We
We
have
have
the
the
statistical
statistical
number
number
14.952,
14.952,
and we
and
have
we have
the
the
number.
number.
This
This
is
is
T.
T.
So I
So I
explain
explained
in
in
the
the
PowerPoint.
PowerPoint.
So we
We
can
can
select
select
the
the
weight.
weight.
In
In this case, the variable is the weight,
Then
and
we
then
can
we can
select
select
the
the
subgroup
group
is
is
the
the
species.
species,
And
and
we
we
want
want
to
to
display
display
by
by
comparing the
comparing
mean.
the mean.
This
So
is
this
the
is
comparing
comparing
the
the
mean.
mean,
And
and
you
you
can
can
select
select
or
or
unselect
unselect
the
the
annotate.
annotate.
If
If
you
you
select
select or
unselect,
unselect,
it
it
depends on
depends on the
the
version.
you can
You
see
can see
the
the
ANOVA.
ANOVA.
Okay. So the
So the
analysis
analysis
is
is we can use the
P value,
p-value,
or
or
this is
this
the
is the
statistical
statistical
hypothesis
hypothesis
testing.
testing.
For
For
this
this
ANOVA,
ANOVA,
it
it
means
means
they
they
will
will
check
check
based
based
on
on
the
the
statistics
statistics
whether
whether
all
all
the
the
averages
averages
are
are
same
same
or
or
not.
not.
It
It
means
means
we
we
can
can have
the
the
hypothesis
hypothesis
mu1 is the
is the
average
average
of
of
the
the
fish
fish
number
number
one,
one,
whether
whether
it
it
equals
equals
to
to
the
the
mu2. Mu is
is
the
the
average
average
of
of
with
weight
the
of
fish
fish
number
number
2,
two,
and
and
then
then
mu3,
mu3,
mu4,
mu4,
mu5,
mu5,
until
until
mu6.
mu6,
Oh,
or
maybe
maybe
you
you
have
have
7
7
fish.
fish.
So
So
we
we
want to
want to
know
know
if
if
all
all
the
the
average
average
of
of
these
these
fish
fish
are the
are
same
the same
or not. A
A
common
common
standard,
standard,
if
if
p
p
value
value
is
is
less
less
than
than
0.05,
0.05,
then
then
it
it
rejects
rejects
the
the
hypothesis
hypothesis
that
that
all
all
means
fish
are the
are
same.
the same.
So
So
based on
based
the
on the
statistical
statistical
hypothesis,
hypothesis,
the
the
or the
the
hypothesis
hypothesis is one.
we
We
want to know
want to know
whether
whether
all
all
the
the
mean
mean
are
are
the
the
same
same
or not.
or not.
So the
So the
hypothesis
hypothesis
is
is
all the
all the
averages
averages
are the
are
same.
the same.
If the
If the
p
p
value
value
is less
is
than
less than
0.05,
0.05,
then
then
we can
we
say
can say
that
that
this
this
fish,
fish,
one
one
of these
this
fish
is
is not
not.
because we
Because
have
we
the
have
p
the p
value is
value
less
is
than
less than
0.05.
0.05.
In this
In this
example,
example, it means that
the
the
mean
mean
or
or
average
average
width
width
for
for
every
every
species
species
are not the same. Then,
then
by
by looking at the question here,
do you
do
think
you
the
think the
average width
average
for
width
all
for all
species
species
are the
are
same?
the same?
Explain.
Explain.
So we can write
Right.
in
In
the
the
orange.
orange,
Number
number
3.
3,
Since
since
the
the
p
p
value
value
is
is
0,
0,
then
then
the
the
average
average
width
width
for
for
all
all
fish
fish
are
are not
the same.
the same.
Okay, so
So you can write something like this.
next, what
What
are
are the distribution frequencies
of the
the
fish weight?
fish weight?
The
The
distribution
distribution
frequencies
frequencies means
the
the
distribution
distribution
here.
here.
So
So
I
I
can
can look again on the distribution.
So if I look
I
at
look
the
at
weight,
the weight.
this is
This
the
is
weight
the weight
distribution.
distribution.
In the
In
weight
the weight
distribution,
distribution,
we
we
can
can
split
split
the
the
column.
column.
So
So
here
here
we
we
know
know
that
that
there
there
are
are
many
many
ways
ways
with
the weight
80.
80.
Oh, sorry.
Sorry.
There
There
are
are
weight
weight
between
between
0
0
until
until
maybe
maybe
this is
this is
500,
500,
this is
this is
400,
400,
300,
300,
200,
200,
100, and
100,
this
and
is
this is
50.
50.
So
So
between
between
0
0
until
until
50,
50,
we
we
have
have
18
18
phases.
phases.
Between
Between
50
50
until
until
100,
100,
there
there
are
are
12.
12.
Between
Between
100
100
until
until
150,
150,
this
this
one,
one,
it
it
has
has
22
22.
and so on.
Yes.
Now
Now
we can
we
take a
can
look.
take a look.
So
So
what
what
are
are
the
the
distribution
distribution
frequencies
frequencies
of the
of the
fish
fish
weight?
weight?
You
You
can
can
make
make
this
this
on
on
the
the
species.
species.
So
So
if you want to know
know
based on the fish weight like this, if I
if I
split
split
this on
this
the
on the
species,
species,
then
then
this is
this
the
is the
distribution.
distribution.
And you
And
can
you can
also
also
set
set
up
up
different pin.
pin.
If you
If you
still
still
remember,
remember the pin,
pin
pin
means
means
the
the
range
range
value
value
that
that
you want
you
to
want to
specify
specify
when
when
it
it
is
is
a
a
numerical
numerical
element.
element.
Now
Now
you
you
can
can
look at
look
this
at this
one.
one.
If you
If you
increase
increase
the
the
pin
pin
for
for
every
every
1,000.
1,000,
So if
if
it
it
is
is
for
for
1,000,
1,000,
it means
it
I
means I
want to
want to
know
know
how
how
many
many
fish
fish
in
in
the
the
weight
weight
between
between
0
0
until
until
1,000
1,000
and
and
1,000
1,000
until
until
2,000
2,000
and
and
then
then
2,000
2,000
until
until
3,000 and
3,000
so on.
and so on.
But
But
this
this
on
on
this
this
information,
information,
we have
we have
only
only
the
the
range
range
until
until
2,000,
2,000,
which is
which is
the
the
maximum.
maximum.
So
So
if
if
I
I
say
say
like
like this one,
if I
if
use
I
the
use the
pin
pin
with
with
1,000
1,000
or the
or the
maximum,
maximum,
it
it
seems
seems
that
that
most
most
of
of
the
the
fish
fish
weight
weight
it
it
is
is
below
below
than
10
1,000.
1,000.
And
And
some
some
of
of
the
the
fish
fish
are
are
above
above
1,000.
1,000.
And
And
yeah, using the
the
distribution,
distribution,
it
it
shows
shows
the
the
frequency
frequency
of
of
the
the
fish
fish
weight
weight
distribution.
distribution.
So most
Most
of
of
the
the
fish
fish
weights
weights
are
are
below
below
1,000.
1,000. So
Most
most
of
of
them
them
are
are
below
below
1,000.
1,000.
And
And
then
then
first
first
has the
has the highest frequency when the fish weight is below
1,000. So you can see here,
here.
when the
When the
weight
weight
is
is
below
below
1,000,
1,000,
we
we
have
have
92.45%.
92.45%. Okay.
So
So
you
you can see the
statistic.
statistic.
So
So
if
if you move your mouse here,
you can
you
see
can
the
see the
statistics
statistics
of
of
this distribution
distribution
of
of
the
the
fish
fish
weight.
weight.
If you
If
move
you move
here,
here,
then you
then
can
you can
see
see
also
also
the
the
distribution.
distribution.
It has
It has
only
only
7.55%
7.55%
among
among
the
the
top
top
fish.
that
That the
the
weight
weight
is
is
higher
higher
than
than
1,000.
1,000. Okay.
And
And
the
the
fish
fish
first,
first, which is the yellow,
that
that
this
this
shows
shows
the
the
highest
highest
frequency.
frequency.
Okay.
Okay.
First
First
shows
shows the highest frequency, which is 50
fish.
fish.
And
And
the
the weight is less than 1,000.
Okay.
Okay.
So
So
that's
that's
about
about
the
the
ED.
ED.
And yeah, you
Yeah,
can
you can
look
look
at
at
the
the
different
different
questions
questions
later,
later,
how
how
to
to
solve the
solve the
problems
problems
based
based
on
on
the
the
questions.
questions.
For
For
example,
example,
now
now
I'm
I'm
showing
showing
how
how
to
to
use
use
the
the
scatter
scatter
plot.
plot.
So you
So
can
you
use
can
the
use the
scatter
scatter
plot.
plot.
If you still
Still
remember,
remember,
scatter
scatter
plot
plot
is
is
to
to
see the
the
relationship
relationship
between
between
two
two
numerical variables. Let's say
Let's say
I'm
I'm
using
using
the
X,
x
which
is
is
length
length
1
1
and
and
y
Y
is
is
length
length
2.
2.
Okay, it
It
seems
seems
it's
very,
very
very
good.
good.
between length
length
1
1 and length 2.
Now let's see if I want to see the height and weight. Is there any relationship between the height and weight? If you look at this one, I can see the relationship between the height and weight. So the R is 0.72. So this R means it is the relationship function. If it is closer to 1, then it is highly positive correlation. If it is closer to 0, then it is no correlation. We can see that this is quite high. This is 0.72. If there is a question about what is the correlation between the height and weight, so show the R value, then this is the value. So this value, you can look at this option. So let's say you can omit the regression line. So if you put the regression line, you will see this line. If you unclick the regression line, then the regression line will disappear. Okay. So there is option here. So please make sure you understand this option. And also you can set up the attributes, which attribute that you want to use to draw the diagram. Let's say I'm using the species. Then this is the scatter plot for different species. For the bream, this is the line. For the parky, this is the line. For the yellow, so this is the line. And so on. And using this scatter plot, we can also look at the R, the correlation value. This R is 0.4, this R is 0.8, this is 0.97, and so on. Yeah, if you need to answer some problem about the correlation value, you can mention this number. So for example, this one, by choosing the height and weight, it shows high correlation by the highest R value, that is bream. Bream with value 0.98. Okay. If you need to write down something, first you know, you can write here. Bream has R value 0.98. And for example, if your region now becomes very complex, it is difficult to understand. This answer belongs to which region? This answer belongs to which region? Then you can use the arrow. So using the arrow, you can set up like this one. So using the arrow, you can set up like this one. So I know that okay, this belongs to this region. And also you can also look at this one. If you do the right click, you can rename it. You can rename. For this rename, we can change the widget name. This is feature statistics for bream. So you can also do the rename. This is feature statistics for parky, for example. And so on. So every widget you can specify their specific. Now, in the modeling, we call it modeling. So you learn a lot of machine learning or model now. Let's suppose we have 5 questions. Run three different algorithms show the result
of test and score,
and
and what is the best
algorithm.
algorithm. Describe the parameter that you use for this experiment. What is the most important features?
Explain
Explain using the feature importance.
and
And
what is
the best model?
explain using the
the
explain model. So you already did this one during the assignment. So if you did
Did
the
the
assignment
assignment
well,
well,
because
because
you know. So let's just do very
very
simple
simple
with
with
the
the
decision
decision
tree.
tree.
And
And
today
today
I'm
I'm
going
going
to
to
explain
explain
how to figure out the parameter.
parameter.
So
So
three. So in the decision
in the decision tree,
you
you
can
can
see
see
there are
some
parameters.
parameters.
What is
What is
parameters?
parameters?
The
The
parameters
parameters
means
means
how
how
to
to
define
define
the
the
tree.
tree. So the tree.
This
This
is
is
tree.
tree.
So
So
there
there
are
are
three.
there are some parameters.
The
The
first
first
parameter
parameter
is
is
the
the
induced
induced
binary.
binary tree.
Induced
Induced
binary
binary
tree
tree
means
means
the
the
tree
tree
will
will
have
have
only
only
two
two
or
or
binary
binary
branches.
branches.
So
So
if
if
you have the node, then
then
the
the branch will be only two.
the
The
branch
branch
will
will
be
be
only
only two.
the
The
branch
branch
will
will
be
be
only
only two.
that
That
is
is
the
the
meaning
meaning
by
by binary tree.
but
But
if you use
the
the full
full
tree,
tree,
if
if
you
you
do
do
not
not
click
click like this one,
then
then
it
it
means
means
the
the
tree
tree
can
can
have
have
many
many
branches.
branches.
So
It
it can
can
be
be
many
many
branches
branches like this one.
The
The
minimum
minimum
number
number of instances in
leaf,
leaf,
you know, in the tree, we have leaf. Leaf means the
the
last
last
node.
node.
So in
So
the
in the
last
last
node,
nodes,
we
we
want
want
to
to
check
check
how
how
many
many
instances
instances
in
in
the
the
leaf.
leaf.
So
So
in
in
here,
here,
if
if
we
we
set
set
2, it
it
means
means
the
the
minimum number in this
this
end
end of this node,
there will be only 2. Do not
split subset smaller than 5.
If
If
this
this
already
already
5,
5,
there
there
are
are
5
5 instances in this node,
then
limit
limit
the maximum tree depth
to
to
100. So
So
3
tree
depth
depth
means
means
if
if
we
we
have
have
the
the
3
tree
like
like
this
this
one,
one,
then
then
the
the
depth
depth
is
is
1.
1.
If
If
we
we
have
have
like
like
this
this
one,
one,
then the
then the
depth
depth
is
is
1,
1.
2. Stop when the
When the
majority
majority
reaches
reaches
95%. So
So
if you
if you
still
still
remember,
remember,
whenever
whenever
you
you
use
use
3,
3,
you
you
can
can
take
take
a
a
look
look
on
on
the
the
3 view.
view.
So yeah, in the 3 viewer,
viewer,
we
we
have
have
actually
actually this is not the
classification,
classification,
this is
this is
regression,
regression.
and then
then
you
you
can
can
have only
only
the
the
average
average
with
with
the
the
variance.
variance.
And in this step,
step,
we
we
can
can
set up
if you want to have the unlimited.
So the tree will be very
complex like this one.
Okay. So it is difficult to understand how to analyze this tree. That's why it is better to limit the depth of the tree. If we call 4 levels, so it means the depth is 4. So 1, 2, 3, and 4. We have the KNN. So in the KNN, you can define how many K. And then what is the metric that you want to use? So you already learned the distance, whether it is using the Euclidean or the Mann method. So you don't need to use the cap and analysis. I think the ingredient will be enough. And the weight, whether you want to use the uniform or the by distance, just make it as the default to analyze the data. And the other algorithm is the linear regression. In the linear regression, there are some other parameters. So in the linear regression, there are some other parameters, for example, the risk regression, lasso regression, elastic net regression. So I will not explain this one. So let's just use the no regularization. This is the basic one. And then you can check with this basic what is the result. And you know from this, we can set up the performance measure. Because this is using the regression, then the performance measure will be the R square or the R. So you can go to the test and score, test and score, test and score, and then connect the data. Then you will see. Using this one, we need to select which one is the best. So there are two options, whether you want to use the cross validation or you want to use the random sampling. You already know what is cross validation, what is random sampling. So let's say I'm using the cross validation, then the best result is decision tree. Why? Because it shows the high R square value and the small error value. So the error here is the smallest. This is the smallest. Oh, okay, and this is the smallest. But you can see three measures, MSE, RMSE, and MAPE. Three has the smallest one. Meanwhile, KNN only has one method, which is the MA. Then we can say that we select decision tree in this option. If you use different like random sampling, then you can also figure out based on this one. In this case, the best is linear regression. This is the smallest. This is the smallest. Oh, okay. Again, the KNN is the smallest, but linear regression shows three different measures with the smallest and the upper, which is the highest. So we will select the linear regression. Then you can analyze again. Linear regression is the best model based on the RMSE, MSE, R square, and MAPE. So you can define like this. Okay, so I give you the explanation. Here R square, MSE, MFG, MAPE, MAE. Although KNN shows the best on MAE, but linear regression still outperform 3 among 4 error measurements. So the remaining is to show about the prediction result. So the prediction is, I think I will not discuss this one. This is just for your team project. If you need to do this prediction, you can analyze this prediction. And of course, in this exam, we will do until explain the model. Explain the model and explain the important features. So based on this one, the important features is length 2 and length 1. And based on this one, length 2 and length 1 affect the model. Because it shows the red color when it is in the positive and it is in the negative one. Yeah. So this is only the definition, but you will have some question maybe about the clustering, classification, or the association rule. Okay, if you watch the video that I give to you is about the association rule. So please watch the video before the exam, so you can know how to do the association rule with this. Okay, that's all for today.